Hello learners, welcome to the world of group theory, crash course day 5. In previous video, we discussed about the point group and how point group is classified into 3 types, and we see about the points group types. It's classified into low, medium and high symmetry point groups. In previous video, we discussed about the low point group and first 3 medium point group. In today's video, we see about the remaining 4 point group. Before that, what is the use of point group? Point group is the one of the basic and important topic in the BSc and MSc physical chemistry. We are expecting the questions from BSc and MSc semester question papers. After that BSc MSc, the point group is asked for the CSIR net. CSIR net in CSIR net question paper, point group is asked for the 2 marks and 4 mark question papers, and also the set, and in set exams also we expect the questions from the point group. So group theory is the one of the major and important topic for the all competitive examination. Even GATE exam also has the questions from group theory. So in today's classes, we see about the remaining 4 medium point group, some point symmetry group. Then go to the lesson. The first we see about the DN point group. Before we know that DN is equal to 2, 3, 1. In DN point group, it has the rotation identity matrix. It has identity matrix E and also one CN rotation compulsory, and also it has the C2 rotation also. So a Cn plus a number of C2 rotation is equal to Dn. So it has both Cn and C2 symmetry, C2 rotations. So we have the example for the rotile complex here. Here it has the 3 C2 axis, C2 fold axis, and also it has the C3 rotation. After 3 rotation, it has come to the original position. So it has the C3 rotation and also 3 2 fold axis and also one identity matrix. So it has the D3 rotation. Next, we have the example for the XeFe4. The XeFe4 also has the 4C2 rotation and also 1C4 rotation. We rotate the molecule like if this is F1, this is F2, this is F3, this is F4. Up to 4 rotation with the basis of 90 degree, we rotate the molecule and get back to its original position. So we have the C4 rotation and also it has the 4C2 based upon this and based upon this and based upon this, based upon this, we get the 4C2 fold axis. So it has the 4C2 and 1C4 rotation. So XeF4 belongs to D4 point group. Then we move upon to D and D point group. The first time in the point group we see the D. In previous video we see about the V and H symmetry only. In this D and D has the dihedral symmetry. For example, alene. Alene has the D and D point groups. For example, it has this is the alene structure. It has the identity and it has the 2 rotation. After second 2 rotation, like that, this is 1, this is 2, this is 3, this is 4. We have to rotate like this. This goes up and this goes down. So up to 180 degree, we have to the 2 rotation, and also it has 2 C2 fold axis like that. By this folding and also by this folding, we have the 2 C2 fold axis, and it has the dihedral. This is the dihedral of one dihedral plane, and this is the one dihedral plane. So it has the 2 dihedral plane. So this alene has the D2D point group. This alene has the D2D point group. And next we see about the S6 point, SN point group. Staggered ethane is the very important, and every time as the most of the time as the in CSIR net and gate question papers or even those set question papers are asked the point group for staggered ethane or S6 point group belongs to what. So we expect the questions like that. So the staggered ethane is a very standard example for the S6 point group. Here, this is the structure of staggered ethane. By using this projection, the staggered ethane has the E identity matrix and one C3 rotation and two C2 fold axis, and it has also dihedral plane and also identity inversion matrix. So it has the S6 point group. The staggered ethane is the very important one. So you remember about the staggered ethane point group and what is S6 point groups. Next, we move to the DNH point group. DNH for the DNH point group, the BCl3 is the common example. For BCl3, we see that it has the identity matrix. We also know about all the matrix or have the identity matrix, and it has the C3 rotation. For this is the C1, this is the C2, and the Cl2, this is the Cl3. So we rotate this molecule like with based upon the 120-degree. So it has the C3 rotation, and also it has the 3 C2 fold axis. This is the one fold and this is the two fold. This is the three fold. We fold the BCl3 up to the 3C2, and it has the horizontal plane of symmetry. It have been cut with when they cut the molecule, it's bisect the each other and horizontal um, plane of symmetry, and it's also have the vertical plane of symmetry also. But by the priority goes to what horizontal plane only. So we have the H in the last position. The C3 plus 2 3C2 in the fold axis gives the D3 point group. So it has BCl3 has the D3H point group. In today's classes, we have the medium point symmetry groups, and also we see the how it's classified into four types and what are the example, and how the point group is important with the basis of BSc and MSc and also CSAR net and gate exams and exams. So I hope we are enjoying the point group sessions. In next video, we see about high point symmetry groups. Thank you for watching. Thank you.